All right, we're back. We're on page 4, notes 18, Calc AB. We're talking about average value, integral over interval, not to be confused with average rate of change, which is algebra 1 slope. So average value of a function, integral of the function over the interval of the function. Yeah, and you're going to directly calculate those, and you're going to use fundamental theorem and whatever. I find that it's very, very common, however, that you're going to actually be given a table of values and approximate the average value. And when you do that, do not forget that it's going to be 1 over b minus a, right? It's 1 over b minus a times the integral from a to b of whatever. The other thing is, if you look at like the units in the middle of an average value problem, so say you have a function, right? You got your function. I'm going to call the function t of, I want to call it like t, let's call it capital F for Fahrenheit, I guess, of t, and then you got t, and we'll say this is in degrees Fahrenheit, and this is in hours. So when you go to find the average value of f of t, the average value of f of t will have the same units as f, because it's just a y value of that function. So the units are going to be degrees Fahrenheit. When you do your calculation, you're going to go, I don't know, let's say from here to here, right? So you find this area, blah, 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 the whole area, you're going to find, what are the units on that area? Well, the units on that area are degrees Fahrenheit, right? The y value times hours. So they're degree Fahrenheit hours. The intermediate units that you get on these things are kind of ridiculous, and I love thinking about them. The reason that your final answer works out to being degrees Fahrenheit is because you're then going to divide by hours. So you go degree Fahrenheit hours divided by hours gives you degrees Fahrenheit. So the units will work. The intermediate middle units, though, crazy if you think about them. And no, you never really think about them, so it's kind of okay. But let's see if we can do this. So table below gives values for f of x and its derivative f prime. Approximate the average value of f of x on the interval from 1 to 9 using a right Riemann sum with 4 intervals as indicated by the table. Okay, I think we got that. So what you should do, always start out with the proper calculus notation. So average value of f of x. So I'm going to do the integral from 1 to 9 of f of x dx divided by 9 minus 1. Okay, so now I'm going to say this is approximately, because we're approximating it from a table. So approximately, do not forget the 1/8. I would say that's almost 100% of the errors that I see my students make, is they just forget to carry that forward into the approximation. You get so excited about approximating that you forget, like, oh yeah, there's a thing I'm supposed to do. All right, we're using a right Riemann sum. So the first base is from 1 to 3, so that's 2. And then a right Riemann sum, so we're going to use the right endpoint, so 5, plus, we go from 3 to 4, which is 1, and we use the right endpoint, which is 4. Then we're going to go from 4 to 6 is 2, and we use the right, so 7, so 2 times 7. And then we're going to go from 6 to 9, which is 3, and we use the right endpoint, which is 2, so 3 times 2. So we get 1/8 of, you could leave this on the AP exam the way it currently is without that equals 1/8 nonsense. You don't have to simplify. I think it's always good to simplify because, like, I don't know what the average value is, but I know that it's not more than 7 and it's not less than 2, right? So like you get a really good sense. So if I do my calculation and I get like 9, I know that something is wrong in there. I think there's value in simplification is what I'm saying. So 10, 14, another 14 is 28, and then 6 is 34. So I think we get 17 over 4. The one caveat to simplifying is, if you leave it unsimplified, you're good, you're done. If you simplify it and get it wrong, you lost the point. So it's actually riskier. Like you probably shouldn't do it. I'm probably telling you the wrong thing to say simplify it. I just think it's useful to simplify it. You could simplify, get the value, be like, that's reasonable, and then like cross out your work. I don't know why you would do that either, but like, I guess you supposedly could. Anyway, let's just check it. So 10, 14, another 14 is 28, and then 6 is almost definitely 34. So I think that's good. Approximate, we're just doing the average value again. trapezoidal sum with 4 subintervals. Okay, so trapezoidal sum, so we're going to say the average value. So I'll just do, whoops. I'm just going to write it as 1/8 the integral from 1 to 9 of f of x dx. Got to vary it up, you know. Always try to think of other ways you can represent things. Is approximately 1/8. Okay, and then there's a 1/2 because we're doing trapezoids. And then let's see. So the first one, you're going to go, the height is 2, and then 3 plus 5. 2 times 3 plus 5, so 2 times 8. This is how I usually do these. And then it's going to be 1. So you go from 3 to 4 is 1, and then 5 plus 9. 5 plus 4, so 1 times 9. Plus, we go from 4 to 6 is 2, and then add those, and you get 11. 2 times 11. So 2 times 11 plus from 6 to 9 is 3 times, add those, you get 9. 3 times 9. So like, I really don't want to simplify this. And I could choose not to and be totally fine, but I'm going to do it anyway. So this is 1/16 of 16. Let's do it like a piece of, should we do a piece of time? 16 and 22. So what I'm doing, I do these kind of in the way that makes the most sense to me. 16 plus 22 is 38, so I'm going to write 38. And then 9 plus 27 is 36. And then what we could do is, I don't know, like you could divide out a 2, I guess, and get like 19 plus 18 over 8. 19 plus 18 over 8. 19 plus 18 is 37 over 8. How do these compare? This would be 34 over 8 and 37 over 8. Like, they're pretty close, so I think it's probably right. I don't know, I'm not going to use a calculator, but like, you also, if you have a calculator available, why are you not using your calculator? Okay, write the equation on the tangent line at 6, use it to approximate f of 6.1. So I need to know what f of 6 is and f prime of 6. So I'm just going to jot them down here. So f of 6 you can read in the table is 7. F prime of 6 you can read in the table is 4. So I'm going to bring these with me back down to the problem. That's the easiest way for me to deal with that. If you've printed out the notes or if you're looking them on another screen, you can just like see it. I don't have that. Also, I think like it's good for you to see me get the values. So I don't know. Can't win, you know. So this is my tangent line. So let's label it tangent line. And then approximate f of 6.1. So f of 6.1 is approximately 7 plus 4 times 6.1 minus 6 is 0.1. 7.4. Approximately 7.4. We don't know if it's an overestimate, an underestimate. We don't have enough information. But that's my approximation. Approximate f prime of 2. Okay, so remember, when you approximate f prime of 2, you don't use the values of f prime. You actually use a secant line. So I'm going to use a secant line, the values that are the closest, one on the left, one on the right of 2. That's my plan. So let's go up and let's steal those values. So 2 is right in between 1 and 3. It doesn't even matter if it was right in, like if it was approximate f prime of 2.8, I would do the same thing. If it was approximate f prime of 1.3, I would do the same thing, because you go one to the left, one to the right, and you know there's a big gap there. So f of 1 is 3, f of 3 is 5. I'm going to bring these with me. So I'm going to do the secant line through those points. Okay, so f prime of 2 approximately. Okay, big deal. We're estimating. This is an approximation, so you got to do that. And it'll be, I like to show the work. So f of 3 minus f of 1 over 3 minus 1. And then that's actually equal to 5 minus 3 is 2 over 2 is 1. Interesting. Okay. Write the equation of the line tangent to g of x, the inverse of f of x. Tangent to the inverse happens a lot. Okay, so x equals 3 that we're at x equals 3. The x equals 3 that we are given is an x value here of g of x. Therefore, it's a y value of f of x. So that's important because what we want to do is go up to the table and we're going to look for a y value of f of x that's 3, find that ordered pair. So we're going to look for a y value of f of x that's 3. Here we go. So 1, 3 is on f of x. So 3, 1 is on g of x. And so I'm going to bring that with me. Let me just bring that with me right now. So this is information that I need, or at least want. No, I guess I need it because I'm doing the tangent line. And then the other thing that I need to know is that g prime of 3 is 1 over f prime of 1, right? Because the ordered pair on f of x is 1, 3. On g of x is therefore 3, 1. And the slope at 3 on g of x is 1 over the slope at 1 on f of x. So therefore, 1/2, let's bring this with us. And then we will answer the question. Okay, so our tangent line, I'm gonna do it here. Tangent line. So make sure you use the right point. This is, double tap. This is the point that we want to use. So we're gonna use this. So it's gonna be y minus 1 equals 1/2 x minus 3. Super good table problem. Good review, right? Derivative of the inverse comes up a lot. Approximating derivatives, that comes up all the time. It's like almost always on one of the first questions of the AP exam for response, which is nuts, right? Because it's just like average rate of change, but whatever. And then average value, when you're approximating it, do not forget 1 over b minus a. Don't forget to bring that with you when you do your approximation, right? It's got to go. And then any approximation needs to be an approximately equal to. So we got them all over the place here, except on this one because that's our tangent line. All right, I'm going to stop this here. I will come back in the next video and do some more. So I will see you there.